G'day viewers, in this episode we're going to define the minimum requirements that the Project Gravitaur team needs to get right in order for their documentary film to be scientifically valid. Our objective in this video is to present the science ahead of the documentary film so that viewers can make comparisons once the documentary film has been publicly released. If the Project Gravitaur documentary film doesn't align with the scientific basis we have derived, then mistakes in the documentary film have occurred. To achieve this, we have utilised and summarised episodes 65, 67 and 68. Anyway, let's get into it. This frame describes the element 115 fuel wedge manufacturing process and instructions for Los Alamos National Laboratory. LANL will receive a set of 12 to 16 element 115 fuel discs. In this illustration, we've overlaid the 12 and 13 disc configurations onto our 16 disc template solution to assist comprehension. What's important to recognise here is that the number of discs supplied can change from batch run to batch run, hence the height of the cone/cylinder can change from batch run to batch run. The disc thickness is set to 1/4 gravity A wave fundamental wavelength. In other words, the gravity A wave phenomenon is effectively switched off, in a manner of speaking, at this thickness. Thus, a minimum of 4 discs stacked one upon the other is required to activate the gravity A wave effect propagating upwards on this diagram. The gravity A wave phenomenon is sufficiently pronounced at 3 gravity A wave fundamental wavelengths so as to be accessed and amplified with greater ease. The fabrication sequence proceeds as follows. Step 1. Measure the thickness of each disc and determine the average disc thickness. Step 2. Calculate R from the average disc thickness according to the equation shown. Step 3. Stack the discs into a cylinder. Step 4. Fuse the cylinder utilising the cold welding method. Step 5. Machine the cylinder into a cone. Step 6. Slice the cone into sections as indicated by the dashed lines in the illustration. Step 7. Mate section 2 with section 2' and repeat for all sections. Once mated with their mirror section, each mated section forms a new wedge. Step 8. The primary wedge is complete. 2 special instructions should be noted. 1. Fuse all mated sections utilising the cold welding method. 2. Collect all milled material and return to S4. Please note that each disc will compress approximately 44 micrometers when cold welding the cylinder. That is, each disc will compress approximately the thickness of a human hair. To complete the fabrication process, you'll need a bit more information. Let's have a look at that on the next slide. Firstly, I need to emphasise that a total of 8 element 115 fuel wedges, including the primary wedge, can be manufactured from a single cone/cylinder. The dashed lines on the illustration denote slicing planes. The cone is sliced along the dashed lines indicated, then the opposing sections are mated together to form a secondary wedge. So section 2 mates with section 2', section 3 mates with section 3', and so on. The angle associated with each slice is displayed in the table. It may be a bit difficult to see, but we've inserted a small red dot in section 8. This indicates the slicing angle associated with this piece. Of course, the rest of the angle values in the table are applied in the same manner. It should be obvious that the height of the cone is equal to the height of the cylinder. However, what may not be obvious is that the height at which the slicing angles commence is always equal to 7/8 the height of the cylinder, as shown in the table. You will have also seen that 2/3 of the volume of the cylinder is milled material. That is, 2/3 of the cylinder is removed. The shavings are collected, smelted and reprocessed into new element 115 discs. This means that manufacturing 5 cylinders of element 115 fuel material produces no waste for an ideal solution. Or in other words, 80 element 115 discs produces 5 cones, which in turn produces 40 fuel wedges, with no material being lost, provided of course that we're able to continue manufacturing element 115 fuel wedges in batches of 5 cones. Let's now look at the element 115 reactor dome and waveguide assembly. In this frame, we see 2 illustrations. By including both of them, the relationship between them becomes very apparent. What it shows is that the space alien vehicle is designed and built around the gravity A wave fundamental wavelength. Mankind is not yet sufficiently advanced to design solutions in this manner, although we could actually do it in many situations. What prevents us from doing it is economics. Our society allows the imaginary concept of economics to govern optimal solution engineering practices. I say that economics is imaginary because it's a man-made contrivance and doesn't exist in nature. That is, we can't dig a hole and find a lump of economics. Economics is a complete and utter fiction. Anyway, on the left-hand side, we see the element 115 reactor and waveguide assembly. On the right-hand side, we see the element 115 fuel wedge manufacturing process. In both illustrations, all dimensions are expressed in terms of the letter R. This means that, irrespective of the value of R, the entire solution scales proportionally. It also means that the ratio of the volume of the primary wedge to the volume of an uncut cone is the same for all values of R. Hence, this is termed the ideal volumetric ratio. The ideal volumetric ratio relates to the optimal solution we saw on the previous slide. Thus, because all dimensions are expressed in terms of the gravity A wave fundamental wavelength, R, it is easy to see that the design of the element 115 reactor and waveguide assembly is optimized. Importantly, the element 115 reactor generates a repulsive gravitational force, not an attractive gravitational force. As you can see on the illustration, the radius of the element 115 reactor dome is 5¼ r, hence its diameter is 10½ r. The fact that its diameter is dimensioned to half a wavelength means that the phase of the gravity A wave inside the element 115 reactor is 180 degrees out of phase with the gravity A wave propagating up the waveguide. Consequently, the direction of the gravitational effect associated with the element 115 reactor is opposite to the direction of the gravitational effect associated with the waveguide. Therefore, if the waveguide is propagating an effect which acts as a quantum vacuum inhibitor and suppresses the Casimir effect, then the element 115 reactor propagates an effect which acts as a quantum vacuum booster and enhances the Casimir effect. This means that the element 115 reactor facilitates the virtual photon creation annihilation process, thereby extracting an elevated population of virtual photons from the quantum vacuum. This increases the gradient of the energy density field in the immediate vicinity of the reactor, resulting in a repulsive gravitational force. Let's now have a look at what the ideal volumetric ratio, that is, the optimal solution we saw on the previous slide, buys us on a nuclear stability diagram. By enforcing the ideal volumetric ratio, whilst satisfying the Lazar primary wedge mass requirement of 223 grams, we're able to identify two potential element 115 isotope candidates. One of them resides on the beach of the island of stability, indicated by the purple circle, whilst isotope 258 is lost at sea. However, just because it's lost at sea doesn't mean that it's an impossibility. It could just mean that it occupies a place where our knowledge of nuclear physics is incomplete. Let's not forget that, prior to Edwin Hubble, standard astronomy thought that our Milky Way galaxy was the entire universe. Moreover, let's not forget that Albert Einstein, the man who bested Sir Isaac Newton, believed that the universe was static, that is, not expanding. We now know how ridiculous this idea was, and it came from Einstein, no less. Anyway, the point I'm making is that scientific history is littered with bad ideas, and the idea of isotope 258 stability being impossible may be one of them. So don't be too certain that it can't be stable, just because an incomplete diagram suggests it. We've also included a polynomial of best fit appearing as the solid red line in the illustration. This is something we had to eyeball because we don't have the actual data points for a mathematical equation. But as you can see quite intuitively, our prediction of 181 neutrons hits the target perfectly. This is very encouraging. Standard nuclear physics anticipates a theoretically stable isotope of element 115 to possess 184 neutrons, that is, an atomic weight of 299. As you can see from the illustration, standard nuclear theory places its estimate midpoint on the beach of the island of stability. This is a very encouraging result. Please remember that we have derived our estimate for a stable isotope uniquely and completely independently from the method employed by standard nuclear physics. This is very telling, very reassuring, and should not be dismissed. Let's now summarise what we've learned. Tabulating the totality of our analysis emphasises the fact that we have derived exact solutions for the element 115 gravity A wave, fuel, reactor and waveguide, all expressed in terms of a single parameter r, that is, the gravity A wave fundamental wavelength. This is an astonishing achievement. In the simplest possible terms, we have solved many of the mysteries associated with the sports model. Please note that the S4 engineering solution sits between the Potter and Storti limits. Moreover, our investigation also concludes that element 115 is most likely to exist as an isotope on the beach of the island of stability, with an atomic weight of 296. However, isotope 258 cannot be conclusively excluded from possibility because it might occupy a place where our knowledge of nuclear physics is incomplete. So, as you can see, we have successfully reverse engineered some of the key principles of operation associated with the sports model. Please continue on to the addendum for more information. Our reverse engineering progress report is further supported by the fact that the agreement between the Storti and Potter gravity A-wave solutions is astonishing, that is, due to the fact that completely disparate methods were utilised. Although Potter did not derive the stated gravity A frequency personally, Potter did in fact numerically define the diameter of the waveguide, and Storti was able to decipher the clue in order to determine the associated frequency. What is particularly important to recognise is that Storti derives the gravity A and B wave frequencies utilising a single equation derived from particle physics. It is inconceivable that the correlation between the information on screen could be coincidental. This concludes our reverse engineering progress report. Paul Edwin Potter states on page 365 in his book titled Gravitational Manipulation of Domed Craft that an element 115 reactor had been built by Bob Lazar's S4 associate, Barry Castillo, which had been built prior to Lazar's arrival at S4. The first rule of physical modelling that any mechanical engineering student will tell you is that mock-ups are almost never constructed on a one-to-one scale. This is precisely why students are forced to study Buckingham Pi theory. It's a physical modelling scaling technique published by Edgar Buckingham in 1914. It allows people to execute research, design prototypes and reverse engineer at a convenient and cheaper scale of reality. This is standard engineering. It is well established, well understood and extensively practiced. So then, if Barry Castillo executed standard engineering practice when he built the element 115 reactor mock-up, he would have built it to some sort of convenient scale, less than unity. If the actual diameter of the space alien element 115 reactor dome has been correctly reported by Potter to be 280 millimeters, then it is almost certain that Castillo would have constructed the mock-up to 1/2 scale. To understand why he would have chosen a 1/2 scale is easy. It only requires 1/4 as much element 115 material. That is, when we approximate the shape of the primary fuel wedge to a triangular prism. Given the priceless nature of element 115 material, building a 1/2 scale mock-up is easily understood. Therefore, the element 115 reactor Bob Lazar played with was a 1/2 scale mock-up. Lazar reported the associated dimensions when he left S4, and sources on the internet continued to report Lazar's dimensions like a parrot, without a rigorous analysis similar to what we have executed in our Bob Lazar playlist. The reality is that the information provided by Bob Lazar doesn't align with the theoretical mass density of element 115 unless the mock-up is constructed to 1/2 scale. By following standard engineering practice and building mock-ups to 1/2 scale, the US government effectively quadrupled its working stockpile of element 115 material. It would not have been difficult for Los Alamos National Laboratory to smelt and recast a certain quantity of element 115 fuel disks supplied by the space aliens into a batch of smaller diameter disks that is, from a full-scale radius of 2r to a 1/2 scale mock-up radius of r as appears on screen. The thickness of each disc must remain constant at 1/4 r across all mock-up scales. If this disc thickness is not preserved, then the cone and wedge manufacturing instructions will need to be somewhat modified. In this frame, we see two representations of the required gravitational interaction between the Earth and Lazar's sports model in order for the spacecraft to hover, as reported by Bob Lazar. On the left-hand side, we illustrate gravity as a wave, which represents the gravitational acceleration at the surface of the Earth. You will obviously notice the 7.46 Hz gravity B wave frequency, which we have derived in episode 50. This corresponds to greater than 99.9% of the value of 9.81 meters per second squared. In other words, one may consider the value of 7.46 Hz to mean 9.81 meters per second squared and vice versa. That's a little simplistic, but nevertheless it is appropriate. On the right-hand side of the screen, we illustrate gravity as information. This explains the manner in which gravity A wave energy is to be delivered into the gravity B wave environment. Please refer to episode 51 for the derivation of the gravity A wave frequency value. As you can see, there are three kinds of digital modulation. Since the energy source is referring to the gravity A wave being generated by the element 115 primary fuel wedge, the frequency is utilised raw and unmodified. Hence, we may discard the frequency and phase shift keying options appearing in the illustration. Thus, the remaining form of digital modulation relevant to the sports model is amplitude shift keying, emphasised by the red box appearing on screen. Okay, let's now pull everything together. In order for the sports model to hover at the surface of the Earth, a gravity A wave somewhere between 11.24 GHz and 11.39 GHz is digitally modulated and pulse released towards the centre of mass of the Earth. This means that millimetre wavelength gravity A waves are passing through the hull, as indicated in the diagram. We expect these wavelengths to be somewhere between 26.32 mm and 26.67 mm.